An interface is used to specify members that deriving classes must implement. They are defined with the interface keyword, followed by a name and a code block. Their naming convention is to start with a capital I, and then to have each word initially capitalized. The interface code block can only contain signatures, and only those of methods, properties, indexes and events. The interface members cannot have any implementations. Instead, their bodies are replaced by semicolons. They also cannot have any access modifiers since interface members are always public. In the following example, an interface named iComparable is defined with a single method named compare. The class MyCircle can implement this interface by using the same notation as is used for inheritance. The MyCircle class then needs to define the compare method, which for this class will return the difference between the circle radiuses. The implemented member must be public, in addition to having the same signature as the one defined in the interface. Although a class can only inherit from one base class, it may implement any number of interfaces, by specifying them in a comma-separated list, after any base class. iComparable demonstrates the first usage of interfaces, which is to define a specific functionality that classes can share. It allows programmers to use the interface members without having to know the actual type of a class. To illustrate, the method here takes two iComparable objects and returns the largest one. This method will work for all classes that implement the iComparable interface, regardless of their type, since the method only uses the functionality exposed through that interface. A second way to use an interface is to provide an actual interface for a class, through which the class can be used. Such an interface defines the functionality that programmers using the class will need. The programmers can then view instances of the class through this interface by enclosing the objects in variables of the interface type. This abstraction provides two benefits. First, it makes it easier for other programmers to use the class since they now only have access to the members that are relevant to them. Second, it makes the class more flexible since its implementation can change without being noticeable by other programmers using the class, as long as the interface is followed.